Hello everyone. In this video, we're going to talk about different measures of central tendency. So the three measures of central tendency we're going to talk about are the mean, median, and mode. And then we're also going to talk about how do you know which measure of central tendency to use for a given data set. Our first measure of central tendency here is the mean. This is probably the one that you're most familiar with, where you're just taking the average of a set of numbers. So all you do to compute the mean is add up a set of scores and then divide by the number of scores. So in this example, we have scores of 10, 5, 8, and 7. We add them and then divide by 4, the total number of scores, which in this case would give us a mean of 7.5. So in terms of statistical notation here, when you look at this, when people use an M, or as we're going to be using in this class, an M, that means it's a sample mean. When you use a mu, which is a Greek letter, that means that you have a population mean. Now the mean is computed exactly the same way for the sample and the population. They're just indicated differently so that readers know whether or not they're looking at a sample mean or a population mean. Another measure of central tendency is the median. So this is just the middle score in a set of scores or in a distribution of scores. So in this example, we have scores of 1, 2, 3, 3, 4, 5, and 6. Right? So we set the scores up in order, right? It's important that the scores be in order. And then whatever score falls in the middle of your distribution is the median. Now, if you happen to have an even number of data points, like in the second example with scores of 2, 3, 4, 5, 6, and 7, you take the average of the two middle data points to get the median. Okay? So that is the middle of the distribution. You have an equal number of scores above and below that median in a set of data. Finally, we have the mode. And the mode is the most frequently occurring score in a set of scores or in a distribution of scores. So for an example over here, we have grades on an exam from A to F. And if we count up the number of scores in each category, right, we have 3 A's, 4 B's, and so forth, you can see that C is the most frequently occurring grade. So that would be the mode of this data set, the most frequently occurring score. For any given set of data, you have to decide which measure of central tendency is most appropriate. So the set of rules you follow is when you have nominal data, you have to use the mode. It doesn't make sense to compute a median or a mean because you can't even put the values in order for nominal data because nominal data is not ordered. So for nominal data, you always use the mode. For ordinal data, you use the median. So when you have categories that you can place in order, but the distances between those categories are not equivalent, it doesn't make sense to take a mean, and so instead you use the median. Now when you have interval ratio data, you'd use the mean unless there are a couple of things that happen. So if there are outliers in your data set or really extreme scores or you have a skewed distribution, you use the median. But otherwise, if you have a normal looking distribution with interval ratio data, you're going to use the mean. So here we have an example of nominal data where we've asked people to indicate their political party. So we have people as Republicans, Democrats, or Independents. And each bar represents the number of people in each of those categories. Right, so Republican, Democrat, and Independent aren't in any order. Right? There's no inherent order to those categories, so it's nominal data. And whenever you have nominal data, you have to use the mode. In this case, the most frequently occurring category with the highest bar is Republican, so that would be the mode of this data set. Now this next slide is also looking at political party, but you'll notice here that we have the same number of people in the Republican and the Democrat categories. In this case, we have two modes, right? Republican and Democrat are the mode. They're both the most frequently occurring categories in the data set. Okay? So you can have more than one mode in any particular data set. So this next example is looking at ordinal data. So here we've asked people to indicate what year they are in school. And so we have freshmen, sophomores, juniors, and seniors. And so these categories are in order, right? So seniors have completed more credits than juniors, who have done more than sophomores, and so forth. But we don't know the distance between categories, right? The distance between any given senior and junior might be as little as 1 credit or as many as 20 credits, right? Or even more. So in this case, the data are ordered, but the intervals are not equivalent, right? So that's what makes it ordinal data. And so we would have to use the median here. Right? It doesn't make sense to compute a mean because the distances between categories aren't equivalent. So we use the median. So in this case, our median that I have listed here came from statistical software. It shows us the median is 3. And you could figure this out yourself as well. I just happen to use software, but you would just, it's the total number of people in this data set is 51. You would find the middle score, and that middle score is the median, where half of the people are higher than that and half are lower. This next example is looking at interval ratio data. And here we've asked students to record how many minutes it took them to complete an assignment. Right? So scores vary quite a bit from around 10 minutes to over 30 minutes. So time that it takes to complete assignment in minutes is interval ratio data, right? Time is interval ratio. And our distribution looks fairly normal, right? At least it doesn't have any, it's not skewed, it doesn't have outliers or really extreme scores. And so because of this, we're going to go ahead and use the mean. And the mean in this case is 24.452 minutes. And we just got that from statistical software for this. In this example, we're again looking at interval ratio data. In this example, students took a multiple choice test with 10 questions, and then we have recorded their scores. So scores could range from 0 to 10, 0 meaning that they got nothing right on the test, and 10 meaning that they got everything right. So this is interval ratio data because the difference between any two categories are the same across the continuum there. However, if we look at that distribution, you can see that it's not a normal distribution in that it's skewed. Most of the scores are clumped up on the higher side, and we have fewer scores on the lower side. The tail of the distribution is pointing toward the negative side. And because of this skewedness to the distribution, we would choose to use the median rather than the mean. Right? The more extremely skewed your distribution is, the more the mean is influenced by these extreme scores or the outliers or the skewedness in the data. In this case, it's not terrible, so the mean and the median are actually fairly close to each other, but we still, in good practice, report the median when the data looks skewed rather than the mean. And that is all we have for this video.